Hello. Um, in this video, I'm going to talk about the first half of chapter 6. We're going to define the momentum. We're going to define impulse. And we're going to go through different cases to explain the impulse. Let's see. So let's start with momentum. We're going to define the momentum. When you see truck, huge truck, and in a Fiat, like a small tiny car, they're both in the same motion. Let's say they're accelerating in similar way, or they're in a constant motion, same speed, let's say. But obviously, the Fiat and the truck that's in the same motion, you can feel like they got a different thing going. Yeah, they have a different inertia. So different inertia having the same motion. We kind of think that when the different inertia in the same motion, they don't have the same thing, right? They kind of have the different things, although they have the same motion. Similarly, instead you have a same mass. This ball is moving. This ball is moving either really fast or slow. It should have a different things. So momentum describes inertia in motion. And that's going to be the definition of momentum. Let me go to the whiteboard. Let's see. Sorry, it's taking a little time. Here. So this is about chapter 6. And chapter 6 is about momentum. Let's think about, we have a same speed. Fiat versus a huge truck. Or instead of that, same mass. It's the same mass. Oh, sorry. Or the same mass. Let's just write it underneath. Same mass. But they have different motion. Fast moving. Or slower moving. Same mass, same speed, but they have a different, so in this case, different inertia, different mass. In this case, different motion. And these cases, they have even though it's the same speed, for Fiat in a truck, they have a different momentum. Also, same mass that has a different velocity, they have a different Sorry, momentum. So I'm going to define what momentum is. Momentum, definition of momentum is mass times velocity. Mass times velocity. Okay, what's the unit for the mass? Unit for the mass we use is, typically we use kilogram. Velocity, we use meter per second. So the unit for momentum is kilogram meter per second, or it could be Newton times second. You're gonna see it later, why. You can use that. We don't have a special unit just to describe the momentum. It's either kilogram meter per second, or it's the same thing, is a Newton times second. So these two are typical units to describe momentum. All right, is mass a scalar or vector? Mass is scalar quantity, right? And velocity, is velocity a scalar quantity or a vector quantity? That's right, velocity is a vector quantity. So here we have a mass times scalar times vector quantity. Therefore, momentum is also a vector. This is a vector. The direction of momentum, direction is parallel to the motion. Its velocity. So it's since momentum is a vector, the magnitude is mass times velocity, or the speed, and the direction of momentum is parallel to the velocity. So this is the definition of momentum. Momentum describes inertia in motion. Momentum describes inertia in motion. So here is the definition of momentum. So we define momentum so we can describe the motion mechanics better. Momentum is mass times velocity, inertia in motion. It's a vector quantity. All right, so this is the definition of momentum. Let's go look at the slide and answer some of the multiple choice answers, questions. Okay. Share screen here. Okay. So you see, the slideshow. Hello. Okay, so momentum is a property of moving things. It means inertia in motion. What it means is that mass times velocity. I have a question here. Can elephant and an ant have the same momentum? Can an elephant and an ant, can they have the same momentum? So elephant has a lot larger mass than an ant. Can they have the same momentum? If so, tell me the example. And then if not, explain why not. Maybe we can discuss this in a discussion. So think about that. Following the definition of momentum, momentum is mass times velocity. Okay. So example of momentum, moving boulder has so much more momentum compared to a tiny little rock that's rolling with the same speed. Or the fast moving boulder has so much more momentum compared to the slower moving one. In fact, if the boulder is at rest, it has zero momentum. Even though the boulder is so large, if it's not moving, it has zero momentum. So when you have a moving object, A, it has momentum, B has energy, C, it has speed, D, all of the above. Well, we haven't talked about energy, but you see the momentum, and it has to have a momentum and a speed, and also it has to have an energy. So the answer is all of the above. When the speed of an object is doubled, then its momentum is A, remains unchanged, or B, doubles, C, quadruples, D, decreased. Doubles, right? Mass hasn't changed, but the object is the same, and the speed doubled, so momentum doubles. Okay. All right, so that's the definition of momentum. Now let's talk about impulse. Impulse is change in momentum. Let me see. Impulse is change in momentum. I'm going to, let's see, go back to the whiteboard. So this was the previous one, impulse. So impulse, now impulse. Definition of impulse. Is changing momentum. So this is the definition of impulse. Let's see. So if it's a change in momentum, right? How can you have a change in momentum? Typically, the object stays the same object. When the object has the change in momentum, that means that you have a final. This is the object, the final momentum, right? Final momentum, mass times velocity, minus mass times initial velocity. So this is going to be the change in momentum, right? Assuming that Mass stays the same. So you're only talking about one mass that has the change in momentum. That means that you have a change in velocity. When you have a change in momentum, that means you have a change in velocity. What is change in velocity? What's the definition of a change in velocity? There is, when you change in velocity means you have an acceleration. When there is how can you have an acceleration? How can an object be accelerated? By Newton's second law, in order for object to accelerate, you have non-zero net force. So let's put all these things together. When velocity changes, there is an acceleration. You have accelerations, you have a change in velocity. When you have a non-zero impulse, you have acceleration, and that means there has to have force, non-zero net force. There has to be a non-zero net force. You have by Newton's second law. So you have a change in momentum. When you have a non-zero impulse, you have a change in momentum, you have acceleration, and you have a net force applied. And so you have some kind of a net force applied on an object to have an impulse. And how long this net force is applied gives a different result. How long in time. So you could be pushing with the 10 Newton for 1 second compared to you could be pushing 10 Newton for a minute, 1 second versus a minute. You're gonna get of course, if you have a 10 Newton pushing for a minute, we'll have a bigger change in momentum. You're gonna have a bigger impulse. So you see that how long this net force applied matters in changing momentum or having an impulse. So how long in time? You can see how long in time. In time, the force acts on the body, acts on the object, right? Matters, influence, impulse. You have a different impulse depends on how long the same constant force acted on an object. Or you could simply have a bigger force or bigger force apply, bigger force or smaller force for the same period of time. Still gives different impulse, different change in momentum. So I mentioned that impulse is changing momentum, and it's final momentum minus the initial momentum. And also, you can see now that impulse is also force times time. Force times time. And also equals to, this is, it means change. This triangle is the Greek letter delta, D, Greek letter delta, change. It represents the change in momentum. So this is the definition of impulse. Impulse is describes the change in momentum, and also it also describes how long the force applied, force times time. Is impulse a vector? Yes. Because force is a vector, time is a scalar. So impulse is a vector. And the unit of the impulse is that it's the change in momentum, so it's the same, kilogram meter per second. Or now you see it's the force times time, so it's Newton times second. And it's a vector. It's either parallel to the force or change momentum. So parallel to its acceleration, right? You see how everything's coming together? Apply the Newton's second law. So this is the definition of impulse. Impulse, by definition, is a change in momentum, and that also describes how long the force is applied. Force times time to have that change in momentum. And you can see that applying the definition of velocity and acceleration and Newton's second law. Let's go back to the slide. Oops. Here. So impulse is a product of force times time. It's a force times time. In equation, you can say force Ft. And also it's the change in momentum. We're going to talk about that. But brief force applied over a short time period produces a smaller change in momentum, right? So then compared to the same force applied over a longer period of time. So you get a different result by having the same force applied for different time interval. Or you push with the same force twice the time, and you get a bigger change in momentum too. Greater the impulse exerted on something, greater the change in momentum. So impulse is Ft and also equals to this change in momentum, delta mv. When the force that produces an impulse acts twice as much time, then an impulse is not changed, or is it doubled, quadrupled, or halved? It should be, if it's the same force and then twice as long, then it should be doubled. Okay. Let's talk about the different cases for changing momentum. Let's talk about different scenario for impulse. So you got that definition right? For the momentum is mass times velocity, and the impulse is the change in momentum, and it also equals to the force times time. I'm going to go back to the whiteboard. Screen sharing. Okay. So let's think about, I'm going to give a different cases for impulse. Let's see, case one. Case one, increasing momentum. So what would be the best way to increase the momentum, to have a bigger change in momentum, right? Let's think about a case like you want to hit something. So let's say the baseball, right? The ball is coming towards you. And so before the ball is hitting the bat, right? Before the ball is hitting the bat, you're going to have a, whatever the velocity the pitcher has throw the ball is moving with that velocity. And then you hit it with the bat. Of course, you have to hit it to change the velocity, the momentum. But you're going to hit with the bat as much, you're going to give as much force as possible to change, so that you can not only change the direction and not only slow down the ball, but also you want to change the direction and you want to bring back with a bigger velocity backward to hit the ball. So let's see here. Imagine that this is the ball that's been hit, and then you have a bat, baseball bat that's hitting. On this ball, at this moment that's being hit by the bat, there's a force exerted on the ball. And to have a bigger change in momentum, bigger impulse. You want to give a bigger impulse on this ball from the bat. So of course you want to have a impulse is force times time. So of course you want to have a large force applied. You want to hit it as hard as you can, but also not just that. You also want to have a contact time as long as possible. This one as big as possible. And so you don't just, also of course you want to give a torque and then give as much force as possible to hit the ball, but also you want to be in contact with the bat so you can exert the force as long as possible. So you want to increase the contact time, increase the contact time. And we call that technique follow through. You want to follow through. Right? You don't just do this. You want to keep exerting force as long as possible. So you see, to have the biggest change in momentum, the technique is follow through. You want to hit it. Same thing with the golf. you're hitting the golf ball, and then with the golf club, you want to follow through. Not, you want to give as much force as possible, and you want to follow through. So this is the case 1. To increase momentum, bigger change in momentum, bigger force, and as long as possible. Case 2. Now let's talk about decreasing momentum. But in this case, so let's talk about decreasing momentum. There is you're on this is also the book also talks about it. So let's say you're on a truck, right? So you're on a truck and you're moving with some velocity. You have some speed. And you have only 2 choices. You find out that your brake is completely broken, completely gone. So you can't stop the car. You cannot stop the car. So in order to stop the car, you have 2 choices. 1, you have a big vertical concrete wall. Or the other case is that you have a big stack of hay. Concrete wall. To stop the car. Which one would you pick to stop the car? Will they have the same impulse? If you hit the concrete wall or a stack of hay, do you have the same impulse? Let's see. Well, initially you're moving with the same speed. So initial velocity is the same. What happens after you use the concrete wall to stop the car? So the final velocity is 0. You're also going to use that, if you use a sack of hay to stop the car, So again, this is also final velocity is 0, the same. So answer is yes, same impulse. Either case, even though you hit the vertical concrete wall or a stack of hay, you're going to get the same impulse, same change in momentum. But you know that it's going to give a big difference if you either hit the concrete wall or hitting stack of hay. And you obviously, it's going to pick the stack of hay to stop the car, right? You're not going to choose the concrete wall to stop the car, even though they have the same impulse. The reason why it's different is that same impulse. So either way, we're going to have a same impulse. Let's see. It's the same impulse. Changing momentum is the same. Changing momentum is also force times time. So to be the same, if you hit the concrete wall, how long does the force exert from the concrete wall to the truck? Quick, right? You're going to have a short period of time exerting a force. So therefore, force applied on the truck is going to be big. And then you have a short period of seconds to stop the car. So you have a large amount of force acted to stop the car. But if you have a stack of hay, it takes a long time to slow down the car and stop the car. So you have a longer period of time to apply the force. So the force requires to stop the car won't be as much. So the force applied to stop the car in a vertical wall, concrete, compared to the stack of hay. Of course, it's a smaller force, bigger force. Smaller period of time, bigger period of time. Same impulse, different result. So you see that you need a bigger force to have the same changing momentum when you have a short period of time applied, or you prolong the contact force to have the small force, then you don't need to have as much force applied to slow down and stop the car. Let's see. I show you so I can show you the video. Let's see.